Welcome to this video. This is for Mosa. She has a problem with these calculations in calculations test 2, I think it's called. I think I gave you the second one before. I should have given you the first one, but never mind. Anyway, here we go. Most submarines travel underwater using electrical power from batteries. The German engineer Helmut Walter designed a diesel engine that could be used to propel a submarine beneath the surface of the sea. Instead of taking air from above the surface of the sea, Walter's engine used hydrogen peroxide to provide oxygen for a conventional diesel engine. Hydrogen peroxide may be catalytically decomposed to give water and oxygen. Catalyst, what's a catalyst? I think we all know what that is. Catalyst, it lowers the activation energy, doesn't it, of a reaction. Okay, lowers the activation energy, increasing the rate of reaction. Okay, it doesn't get used up in the process. It is unchanged. The catalyst doesn't actually change. Constructing the balance equation for hydrogen peroxide. Let me get a nice black pen. Let me see. All right, my computer's a bit slow for some reason. So we have H2O2, two of those, gives us 2 waters plus oxygen. I should have put state symbols in, really. This is aqueous. Normally it's aqueous, could be pure. This is liquid and this is gas. Diesel fuel may be considered to consist of this hydrocarbon, C15H32, which reacts completely with oxygen according to this equation. There it is. To which homologous series? Well, this fits the formation CN H2N plus 2. So therefore, this is an alkane, isn't it? All right, I think we've done the easy stuff, haven't we? Let's move up the paper. Okay. Use the equation above and your answer to A part 2 to calculate the amount in moles of hydrogen peroxide that will provide sufficient oxygen for the complete oxidation of 1 mole of that. Okay, so do we need anything? No, I don't think so. Use the equation above and your answer to 1.2. So we're going to use this equation here. And we're going to look at this. Okay, so first of all, let's completely oxidize this. We need, if you have 1 mole of this stuff, 1 mole, you need 23 moles of oxygen. So first of all, number of moles of oxygen is equal to 23 moles. That's how many moles we need for combustion. All right, as they call it complete oxidation for combustion. Now let's have a look at my hydrogen peroxide equation. 2H2O2 gives 2H2O plus O2. What am I going to write here? Underneath the oxygen, I'm going to write 23 moles. And therefore, underneath my hydrogen peroxide, it's 2 times 23 moles. So the answer is 46. Simple as that. Okay, now I'm sure Mosa, whoopsie daisy, I think that disappeared then. Mosa didn't find that bit tricky. Maybe it's the next bit. Okay, so I'm going to, whoopsie daisy, I'm going to, once I've stopped faffing around with this, I'm going to paste another one here with the next page. Okay, and see if we can do this one. All right. Now, a submarine equipped with a water engine uses 212 tons of diesel fuel during an underwater voyage. The submarine also carried concentrated aqueous hydrogen peroxide. Calculate the amount in moles of diesel fuel used during the underwater voyage. Okay, so if amount of diesel fuel, so in moles, so we have, what do we have? C15H32. This is the molecule, and we have 212 tons. Let me write this over here. 212 tons. Okay, which is 212 times 10 to the 6 grams. We need that, don't we? We need to convert it into moles. So the number of moles of this guy here is going to equal the mass of this guy, which is 212 times 10 to the 6 grams, divided by the relative molecular mass of this. So it's going to be 15 times 12 plus 32. All right, now I'm going to get my calculator out and have a look at that. So 15 times 12 is equal to that, plus 32, 212. Really? That's a coincidence, isn't it? So it's 212 times 10 to the 6 divided by 212. All right, normally when things happen like that, it means you're on the right track. If numbers kind of fall out for you, it means we're doing something right. Let me check that though, just in case. 15 times 12, that's the mass of the carbon, plus 32 hydrogens. Yeah, it's 212. So obviously 212 divided by 212 is 1. So the amount of diesel fuel in moles is 1 times 10 to the 6 moles of the fuel. Okay, of this stuff. Use your answers to that and that. B part 2, which I believe was 46 moles. And C part 1, which is this. Use your answers to that and that to calculate the mass in tons of hydrogen peroxide used during the underwater voyage. Now, if you remember, B part 1, I think it was B part 1, it said 1 mole of C15H32 required 46 moles of hydrogen peroxide. Yeah. Therefore, well, we've got a lot more than 1 mole, don't we? We've got 1,000,000 moles. 1,000,000 moles of this C15H32 is going to require 46 million. Okay, moles of hydrogen peroxide. I should put a 2 there, shouldn't I? All right, so this is moles of hydrogen peroxide, but it wants it in tons. So let's convert moles of hydrogen peroxide back to a mass. So, as you know, the mass is equal to the number of moles times the relative molecular mass. Okay, so the number of moles is 46 million. Times the relative molecular mass of hydrogen peroxide is 34. I've just worked that out in my head. Okay, so that number there times 34. All right, let me clear this. 46 million, 1, 2, 3, 4, 5, 6 times 34. Okay, and I get 1.5 billion grams. So I get 1.564. Let's have a look. 9 times 10 to the 9 grams. But I don't want grams, do I? I want tons, as it says here. So I divide this number here by 1,000,000. So it becomes 1.564 times 10 to the 3 tons. Okay, because 10 to the 9 divided by 10 to the 6, which is this number up here, gives us 10 to the 3. Okay, the exhaust products of the water engine were passed into the sea. What would happen to them? Well, what are the exhaust products? Let's have a look. There's obviously carbon dioxide and water. Okay, now the carbon dioxide is acidic. Okay, and so it will lead to the pH of the sea decreasing around where the submarine was, I'm sure. All right. Anyway, I think that's enough for now. I hope that makes sense. If it doesn't, give us a shout and I'll do another one.